Hi, intermediate algebra students. This is Miss Leminski again. Today we start our last section of Chapter 4. We're going to be looking at Section 4 of 5, Day 1, which is Systems of Linear Inequalities. Before we get going on systems of inequalities, I wanted to make sure we reviewed how to just graph a single linear inequality. So we're going to practice by graphing y is greater than x minus 2. Take a second and pause the video and see if you're able to do that on your own. Hopefully you identified the y-intercept as -2, which means on the y-axis I plot a point at -2. My slope is a little trickier because there's nothing in front of the x, so remember if there's nothing in front of the x it's like a 1. So my slope is 1. If I'm going to think about that as rise over run, it's up 1 over 1. I'm going to rise 1, run 1. So reviewing how we graph an inequality, first we plot 2 points using what we learned about graphing y equals mx plus b. But then after we graph those 2 points, we need to look at this inequality symbol and decide if it's solid or dotted. Now, since it's just greater than, this is going to be a dotted line through those points. I'm going to draw a dotted or dashed line through those 2 points. And if it was greater than or equal to, that's when it would be solid. Last but not least, a graph of an inequality is not just the line itself, but instead it's a region of the graph. So we talked about this idea in section 4 of a test point. I always like to test 0, 0 as long as it's not on the line. And 0, 0 is not on the line. What I mean by testing is I take that inequality, I substitute the x and the y value, and I simplify. And in this case, I get 0 is greater than -2. And you would say, yes, Miss Leminski, that is true. Since 0 is greater than -2, that means that this point, 0, 0, is a solution to this inequality, which means it's included as part of my solutions. That means everything up here. These are all solutions to the graph. I could just keep drawing dots, but instead we just shade that side of the graph. If I would have gotten no, that it wasn't true, then that means it wasn't a solution, so I would shade on the other side. So that's a quick review of how we learn how to graph an inequality. And we need that today, because today we are going to graph a system of inequalities. What a system of linear inequalities is that just means you have 2 or more linear inequalities. So it's made up of 2 or more linear inequalities. We're going to mostly be looking at 2, but it's good to know that you could do more. All right, so made up of 2 or more linear inequalities. So you can see in this case, I have 2 inequalities in the same problem. In order to graph these, I graph them in the same grid. Now you'll notice the one that I just put the purple dot by, y is greater than x minus 2, that was our warm-up. So I'm just going to redraw that in this grid. I did that to save a little bit of time. Okay, so we just went over how we got this graph. And we shaded above it. Now I'm going to switch colors so that you can see this. If you're using pencil, which most of you will be, you'll just want to find a way to be able to do this to stay organized without different colors. Okay, so now I'm going to graph my second one in green. Once again, we do what we did in section 4. My y-intercept is 1, so I plot a point at 1. My slope, there's a negative in front of the x, which means it's a -1 over 1. So from there I go down 1 over 1. Because it's less than or equal to, it's going to be a solid line. So through those 2 points, I draw a solid line. And last but not least, I do a test point. And once again, 0, 0 is not on the line, so I can use that. I take that inequality, and I substitute in 0, 0. And then I ask myself, is 0 less than or equal to 1? And you would say, yes, Miss Leminski, it is. What that means is that is a solution. So for my green line, if I was just graphing that, I would shade down here. Now, the graph itself is kind of your answer, but you want to make sure you do one thing before you walk away from it. The solution to a system of linear inequalities, let's fill that in now, is the ordered pairs that make all of the inequalities true. Okay, so the ordered pairs or points that make all of the inequalities true. So in this case, I have two inequalities. So it would be all the points that make both inequalities true. Well, if I look at this graph and what I got, this very top portion only has purple in it. So it's true for the purple graph, but not the green. Over on the right-hand side, this triangle doesn't have anything, so that's nothing. Down here is just green, so that means it only works in the green. Having said that, if you look at this triangle on the left-hand side, I'm going to switch to black and color it in better. We can see that here there's purple and green. This is where they overlap. And that's what you're looking for your solution to a system. You are looking for the place where they overlap. So anywhere in that region that I just shaded darker in black would be a solution to the system. So for example, I could say that the point -2, 0 is a solution to the system. I could say that -4, 3 is a solution. Those work. The point 2, 3, though, is not a solution. The point 1, -4 is not a solution. Now, the one thing that's a little tricky, so most students usually get the shaded versus not shaded. But then we have to talk about, is the line itself a solution? And here's the key. Anytime it's a dotted lines are never solutions. That's why we made them dotted, because it can't be equal to. But the solid lines that border the shaded region, so this green line is solid. This part right here that touches the shaded region, any point on that part of the line would be a solution. So for example, the point 0, 1 is a solution. However, a point that is off the shaded part, so this is on a solid line, so 3, -2, but it is not touching the shaded region, so that one's not. Okay, so where it overlaps, and then the second piece is solid lines, any point on a solid line that touches the overlap. Okay, so you might want to add some more words, but in general, that's what you're looking for points that are considered solutions. All right, the rest of the lesson is just to practice a few more times. We're going to do one more together because this one was a lot of teaching. So if I just ask you to graph the system of inequalities, once again, this time I'm going to graph the top one in green. So I have y is less than 2x. I find my y-intercept. Well, there's nothing there, so it's 0. Plot my point at 0. Find my slope. That's the thing attached to the x. So 2, which would be 2 over 1. So from here, I rise 2, run 1. I see that it's just less than. So it's going to be a dotted line through those points. 2 dotted. And then last but not least, I test a point. Here's the thing. In this case, 0, 0 is on that line. So I can't use 0, 0. Okay, so I like to show examples of that because it doesn't come up too often, but we need to make sure. Okay, so I can't use 0, 0, so I have to find any other point to check. I could check any point up here. I could check -4, 0. I could check -2, 4. I could check 0, 3. I could check anything over here. 2, 1, 0, or 5, 0, 0, -3. Doesn't matter. It just can't be on that line. For no specific reason, I chose to check the point 1, 0. Okay, so this is the point I checked. Again, you could choose many other options. All right, so I checked 1, 0, which means that I take this inequality, y less than 2x, and this time for y I plug in 0, for x I plug in 1. So I ask myself, is 0 less than 2? I get yes it is, which means that is a solution, so I shade this way. Now the other one, we haven't really looked at this too much, but it only has y is greater than -3. So when I go to find my y-intercept, remember that's the thing on the right-hand side not attached to the x, so it is -3. So I have a y-intercept at -3. My slope, however, is a little confusing. In theory, if there's no x value, I could write it as 0x minus 3, right? This says the same thing. We just don't show that. So that means it's a slope of 0. Well, we talked about anytime there's a slope of just a number, like in the first one, it was a slope of 2, we wrote it as 2 over 1. You could write this as 0 over 1, which means that from this y-intercept, I rise 0 but run 1. Rise 0, run 1. Anytime you have y equals or is greater than or less than just a number, it's going to be a horizontal line because the slope is 0. Okay, so that's why they go straight across. Because it's greater than, it's going to be a dotted line. So it's a dotted horizontal line across -3 on the y-axis. I can test my favorite point 0, 0 because it's not on that line. So I say, is 0 greater than -3? And yes, it is. So I would shade this direction. All right, remember, our solution, we want to make sure we shade in the part that overlaps really dark. Okay, so if you're using the same color, just make sure you shade this section that has both the purple and green on mine really dark. And again, any point in this black region now is a solution to the problem. In this case, since both lines are dotted, there are no points on the lines that would be solutions. It's just the points that fall between this section. Okay, go ahead and pause the video, and then I want you to graph this system and then check your work. All right, so when I did this, the first one, I had a y-intercept of 1. I went down 2 over 1. It was solid because it was greater than or equal to. And when I tested the point 0, 0, I got no, it doesn't work, so I shaded away. When I graphed the other one, I had a y-intercept of 2, a slope of 1, so those are my 2 points. It was dotted because it's just greater than. And once again, I could test my favorite point as 0, 0. When I did that, I again got no, so I shaded above. So my final section that is the overlap was this top triangle in this case. Now again, the green line was dotted, so no point on that line is a solution, but the purple line is solid, which means that from where they intersect along where the shaded region is, any point along this line would also be considered a solution. So any point on this portion of the black line or purple line, and then all of these points of overlap. All right, one last one I want to do with you just to show you a unique situation that comes up every once in a while is an example like this. So last example, if I have y is greater than or equal to -x plus 2, my y-intercept is 2, my slope is -1, -1 over 1. So my y-intercept is 2, down 1 over 1. It's greater than or equal to, so I draw a solid line. I am allowed to test 0, 0. When I plug that in, I get 0 greater than or equal to 2, which is, yes. No, it's not. Silly me. That's what I was confused for a second. Okay, it's not. 0 is not bigger than 2. Okay, which means I don't shade over this, so instead I shade away. If I shade the other graph in green, so y is less than -x minus 2. My y-intercept this time is -2. My slope is once again -1. -2 down 1 over 1. It's dotted because it's just less than. And hopefully you're recognizing that these two lines are parallel. And hopefully that makes sense because we have learned that if two lines have the same slope and different y-intercepts, that means they're going to be parallel. If that happens, when I go to test my test point, I get is 0 less than -2. And once again, I get no, which means I don't shade over 0, 0, I shade away from. If you're graphing a system of inequalities that has two parallel lines, there is a unique case where you actually get no solutions because they were parallel, so they never cross, and we shade opposite directions. So there is no solution in this case because there's no overlap. So if a graph has absolutely no overlap, then there's no solutions. But that is very rare that that happens. Okay, that's all we have for today. Here's a note sheet. You can pause and get it down if you didn't get some of the examples, or you should have it on your Schoology page. You should now go work on your 4-5A Pearson practice. Thank you.